Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. This video is going to highlight bisectors, specifically perpendicular and angular. Now, technically a perpendicular bisector is also an angular bisector because it's bisecting a straight angle, but the way we draw them, the approach is just a smidge different. So let's go ahead and let's just get a line segment for A to B, and we're going to practice that perpendicular bisector. We're going to be doing some application of it, but I want to call back a previous video of where I talked about bisecting things. So we're going to bisect a segment, and we're also going to bisect an angle. Notice I'm just throwing them on here. They have no meaning except the fact that I needed variables or points to label the parts of my triangle. So you can technically do this with doing full circles, but you're going to get a compass. And as long as your compass is longer than halfway, you're good. So I'm going to make mine a little bit smaller. And if you recall, I've talked about instead of moving your compass, move the paper if you're struggling. So for example, I'm going to start here. You can't see it with my hand in the way. And instead of moving my hand, I'm going to hold my hand still, and I'm going to rotate the paper. Now I'm going to rotate my hand because I ran out of room. I have too many things sitting next to me. And I'm going to do the same from the other point. So again, I'm rotating the paper. Now I got to move my hand because I got off. So whichever works better for you. If it works better to make your hand move versus the paper move. And while I still have it set here, I'm going to draw a half circle here, or a quarter circle, third circle, some part of a circle. You'll notice that I eyeballed where A and C were, and they were not equal distance from B, and that's okay. Here we have two X's that mark the spot. Here I just did a half circle, so now I'm also going to come in here and do a mark. And notice I'm using my pencil mark from my compass. That way, from here to the center of this new circle is the same distance as to here. So that's very important, not from A and C, but from where my pencil of my compass crossed this ray versus this ray. Okay, if you can do that much and you can make your picture look like this, you actually have the perpendicular bisector and the angular bisector ready to go. We just need a straight edge. And here we're going to connect the quote unquote top of the football to the bottom of the football, if you want to think about it like that. I always think it makes like a weird squish football. And now we have something that's perpendicular. Or you connect this to this, and we have something that bisected the angle into two equal congruent sides. So if this was a 90-degree angle to begin with, they're each 45. If it was 80 to begin with, they're each 40. So this is half of the whole. Now over here, the neat thing is let's look at this spot right here, that point, as it relates to X and Y. So, looks like I gotta shrink my compass down. That's how far it is from X. It's the same distance from Y. What about this point up here? Well, now I gotta widen this out. That's pretty close, right? Yep. Will that work for any point? Yes. Okay, so all points here are the same distance from X as they are to Y. Okay, so all points on the perpendicular bisector of XY are equal distance to x or y respectively. Okay, and all those points that are equal distance are all on the same line. So one, I just wanted to refresh your memory first of what a bisector was, perpendicular and angular. And now, for now, we're going to focus on this perpendicular bisector. Okay. So let's say I gave you this image. Okay, so we're given perpendicular and we're given that this is congruent to this. Couldn't we then say that, oh, because they're congruent, we have a perpendicular bisector. And because we have a perpendicular bisector, we could say px is congruent to py. We can say this now. Why? Because of the perpendicular bisector theorem. Point P would have to be equidistant because it's on the perpendicular bisector. Now, could we have proved the triangles were congruent first and then did CP, CTC? Absolutely. We could have said, hey, PQ is congruent to PQ, then we have the 90-degree angle, and then we have the segment here. And we would have had side, angle, side. Once we had side, angle, side, could we do corresponding parts of congruent triangles are congruent? Yes, absolutely. In fact, if you ever get stuck on a test and you can't prove it using your new vocab words, can you fall back to old vocab words and actually just roundabout way use the same idea without using the same idea? Yes, there's more than one way. It's kind of like think of getting from where you live to your favorite place to shop. Is there only one road that you can take to get there? Maybe it requires you taking an interstate and a traffic jam has happened for some reason. Could you take an alternate route? That's exactly what the perpendicular bisector theorem. It's the shortcut route. Do you have to use it? No, you don't have to take the shortcut, but can you? Yes. Okay, what if you're given this? Well, now, since these are equal distance from here and here, and this is the right angle, it still is a perpendicular bisector theorem, it's just in reverse. So that's how this can work for you, because the perpendicular bisector helps you just go ahead and jump straight into the fact that the triangles are congruent without stating that the triangles are congruent. So it's a shortcut. Okay, I'm not promising that I am drawing this to scale. Okay, here's a picture and I want to find XW. Okay, and we're going to talk about the Y's here. Okay. Now, one option, okay, XZ is congruent to Z or YZ given angle YWZ is congruent to angle XWZ, also given, because 290s make that 180, right? If it's perpendicular, it's 90 degrees everywhere. And then WZ is congruent to WZ by the reflexive property. So triangle XWZ is congruent to triangle YWZ by the hypotenuse leg theorem. Actually, I should have said 90 degrees, not that they are congruent, equal 90. So this is by the hypotenuse leg theorem. So that means XW is congruent to WY because of CPCTC. Blah. Right? That's a lot of writing. Or given WZ is perpendicular to XY, and that XZ is congruent to ZY, I know that XW is congruent to YW because of the perpendicular bisector theorem. Whew, much faster. Plus we can kind of see, hey, look, if this is the same as this, we can fold on this line, and yep, they're going to line up perfectly. So we know 5n minus 2 is equal to 2n plus 7. Oh no, now we've thrown algebra back into it. What forever shall we do? Let's add our 2. You ever love that whenever your geometry teacher just throws the algebra problems back in at random? Why on earth do they do that? They're trying to get you to learn these new things, but they keep bringing back algebra. The point is that you're going to probably be using these together, especially if you move into the world of trigonometry. So you don't want to lose skills because you take a year off. That's why your geometry teacher is doing this. Did we find the answer to the question? XW, is it 3? No, XW is equal to 5 times n minus 2, which is 13. So your geometry teacher is not being mean when they throw these algebra problems back in at you. They are being very honest in the fact that you can't lose these skills. Okay. So just a minute ago, I showed you and refreshed your memory on how to draw an angle bisector. So we also got to talk about those. Because perpendicular bisectors, they created some things. Angle bisectors also create some things. Oh, helps if I have it marked the right way. I'm going to shorthand this so I don't have to have so many marks on my paper. Oh, I almost didn't mark in the right spot. I need to maybe extend that just a smidge more. There we go. And my handy dandy little straight edge. One of these days maybe I'll actually find a smaller ruler, but hey, this works really well. Okay. So I've drawn that. This says that because you've drawn that, if you were to go from this spot to this spot, it would be the same distance as this spot to this spot. You can actually check that anytime you want by just making a circle as well. Or you can check it with your compass. So yep, that makes a radius. Yep, that makes the same radius. Why is that helpful? Well, if this is the same length as this, and we just cut this angle in half, and they share the center side, aren't those two triangles congruent by? Oh, but it looks like angle side side, doesn't it? It does. However, they share this side. We also measured out specifically for that perpendicular, or for that angle bisector. We measured out equidistance here to here. And so you actually have side, side, side that you can use to prove congruent. So that's the nice thing, is that you can always get that done. Okay, so the measure of angle of your angle here is also now going to match your angle here. So if you can get that going, you also have it. So angle bisectors just give you a lot as well. So let's go ahead and let's see a quick picture of what I'm talking about here. Okay. Most of the time that's what we're doing, is we're saying, hey, here's the rule. Can you apply the rule? That's really what we care about. Okay, so here's an angle. It has been cut into two angles at some point. I'm freehanding, keep that in mind. And we have G, H, I, and J. Okay. HI is going to equal 7. IJ is going to equal 7. The measure of angle HGI is going to equal 25 degrees. Find the measure of angle IGJ. Okay. So HI is 7. IJ is 7. Now I get that I have perpendicular here, and that technically I could do a hypotenuse leg theorem, but I'm not worried about that. So because of this being equal to this, that automatically tells us that this is equal to that by reversing the theorem about angle bisectors. So since H to G to I is 25 degrees, I to G to J is also 25 degrees. Okay, so that's really the big thing, is knowing that when you have a line and you draw its perpendicular bisector, this length will match this length. Okay? When you have an angle and you draw its bisector, right? This length, if I draw it well, I did not draw this well, will match this length. That is definitely not bisecting the angle. So if I made my angle bigger, there we go. Now it works. Okay? And this length will match that length. We could continue to do that. Just knowing that relationship, that's really what it is. Can these be proven with side, 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 side angle, side, hypotenuse leg? Absolutely. That's kind of the point, is that we can fall back to our 4 triangle statements, but we don't have to. So the angle bisector theorem and the perpendicular bisector are just shortcut theorems to help you avoid going full side, 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 side angle, side, whatever. Do you have to do that? No. If you know these 2 rules, you can use them. If you forget them, can you fall back to the other? Absolutely. So just making sure that you're following true statements is a really big deal. Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? And drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.